Good morning, everybody. We're getting ready to do the experiment number 8, which deals with the halogens, the elements of group 17 in the periodic table. Those are all non-metallic elements, and they're the most chemically active of all the non-metallic elements. And then fluorine itself is the most chemically active of all the elements. It's so chemically active that water will even burn in fluorine. Okay, and we're going to study 3 of them: chlorine, bromine, and iodine today. And the first one we're going to make chlorine, which is a gas, and all these compounds are colored. Fluorine is a yellow gas. Chlorine is a greenish yellow gas. Bromine is forms a brownish orange vapor, and iodine forms a beautiful violet vapor. So what we're going to do, we're going to use a chemical reaction between a common material you can get at grocery stores, which is Clorox. Clorox is actually a solution of sodium hypochlorite, NaClO, and this particular one is concentrated at 7.5%. And so I'm going to take that compound, and it reacts with concentrated hydrochloric acid to make chlorine gas. And then you're supposed to calculate from the equation how much of the 12 molar hydrochloric acid I'm supposed to use. And then I'm going to use that amount right now. I'm going to add this is the sodium hypochlorite. It has a slight color to it. I'm going to add it first. And that's 25 milliliters. And now I'm going to add the concentrated hydrochloric acid and see if there's any evidence of reaction. There is evidence of reaction. Can you see that there's a gas being produced? Can you see what the color of the gas is? It is green, isn't it? Can you see it? Let me go turn around here so I can see it too. Yep, you can back up a little bit so it's all at the bottom. And that's what's saving our life. It's a dense gas. It's a yellowish green gas. That's chlorine. Remember we looked at the very active metals? This is some more sodium. I'm going to put some sodium in there, and it's going to float around on the water. I'm just going to put a little bit in there, and it should float around on the water. And then the sodium is going to be clean, and so the sodium should react with the chlorine to form the most famous compound of both sodium and chlorine, known as sodium chloride. I think that's going to be all right. Sometimes it reacts with the hydrogen too. We'll see. Ready? Looking at it. Can you see white smoke being produced? Some of the hydrogen is exploding with the chlorine. Isn't that something? Can you see the white smoke, everybody? That's sodium chloride smoke. We've seen sodium chloride made from the direct combination of the elements. And that should take care of this part. Everybody, I have just a little bit of hydrochloric acid in here. I'm going to add it, and you're going to see the same reaction we saw before in that big cylinder, except that the chlorine is real soluble in the hydrocarbon. So any chlorine produced will dissolve primarily in that hydrocarbon. See, it's reacting before. You see the green color being produced, and it should dissolve in the hydrocarbon. And you should see the kind of a green. Well, let me turn it around because we have the wrong background here. You want to see the color, you have to use the white background, right? There we go. Now, can you see any green in the top? I think you can, can't you? Yep, you can see the green in the top layer, and there's some green in the lower layer too, because chlorine is soluble in both water and in the hydrocarbon. Okay, what I did, I dissolved a little bit of sodium bromide in water, and since chlorine is more chemically active than bromine, it should oxidize the bromide to bromine. The chlorine should oxidize it, and then the chlorine is going to be reduced to chloride ions. So the chlorine, Cl2, is going to chloride ions, and the bromide ions are going to be converted into bromine because chlorine is more chemically active. And bromine is kind of a brownish orange element. Let's see if there's any evidence that we're getting bromine produced. Get it out here, and I'll shake it up a little bit with a stopper and see if there's any evidence. You see it? We're getting some of that yellow precipitate in there too again. I wonder if that's something in the bromide. But you are seeing the orange color in the upper layer, the orangish brown color. Now this is a sodium potassium iodide, and bromine is more chemically active than iodine, so it should oxidize the iodide ion to iodine, and the bromine is going to be converted from bromine, Br2, to bromide ion, and iodine is purple. If in hydrocarbon mixtures, it forms a brown ion, the triiodide in water, if there's enough iodine. Let's see if there's any evidence of reaction. See that very dark color in the lower layer? That's the triiodide ion that does that. Now let me shake it up here and see if we can see any purple, because iodine's purple. It should be primarily in the hydrocarbon layer. See that dark color? That's the triiodide ion, no doubt about it. Now it's so intensely colored now you can't see it, so what I'm going to do is dilute it with some hydrocarbon mixture and see if we can see the purple color. And shake it up a little bit. Whoops, it's kind of tight, isn't it? Now let it settle out, and I think you can see the purple color in the upper layer. Can you see it? Yeah, it's more intensely colored. And then that lower layer has triiodide ion in it, which is a dark brown color. This is the one with the triiodide, and this is the one with primarily the iodine, which is purple in color. Okay, everybody, what I'm going to do is pour a little bit of the hydrocarbon layer off into this other test tube and dilute it some more so I can see the color of bromine better. I mean iodine, because iodine is so pretty you need to see it. Now I'm going to dilute it a little bit more and you'll be able to see it. Just a second here. I'm going to add some of the hydrocarbon mixture and see if it dilutes it so you can see it better. You see the color better? Yeah, you can see it better. Okay, that should be good enough.